but you're not really sure it exists. And here it is. Look at that. So take it away.
All right. So as Amy plugs in the power, we designed a mechanical jellyfish apparatus to be used underwater. You can see the design there. And so how it performs is we 3D printed all of these parts. We assembled them. It's intended to have a waterproof housing. And right now we're going to demonstrate its operation in air, how it would operate underwater.
Okay, so imagine as if it was in water. It uses a pressure sensor or barometer that is inside here to sense ambient pressure. Now, right now, it is actually acting on the change of pressure. So we don't have to calibrate it. All we have to do is keep it low for a short time, and then once it recognizes that it's going up, it'll just keep the motor going until eventually it reaches the surface, the surface of the water, and continued motion isn't going to lower the pressure anymore. So eventually it just stops and thinks that it's falling. So it's just going to fall to the bottom of the tank, And then once it gets down low enough that the pressure is again constant, it'll start moving again.
So it really is, just to clarify, sensing the pressure differential in this room.
Yes.
Which I think is
These barometers
incredible.
are very sensitive. It's pretty amazing. And if it was actually in water, then we would have much greater resolution because water is so much more dense.
What's the pressure differential between the bottom and the top of the floor?
You know that?
How many millibars?
Yeah, it's a couple, 0.5 HPA.
Very small. It's like hundreds of HPA.
Yeah.
So I can go over the mechanical design a little bit since it's a little fancy here. Our plan was, of course, to have it waterproof. We had some leaking problems due to some porous 3D printed parts. But the interesting thing here is how we kept all sensitive components to water in the top part so that they could be covered with this, and we could have a little airtight bubble up here. And then the tricky part was getting the mechanical motion down from the airtight area down into the bottom, and then get the gears to move the arms and stuff. So there's a tube in the middle here. It's called a stuffing tube. It's used on RC boats and stuff, so that you can have a rotating shaft, go from an air environment to a water environment. It's basically just a tube with a lot of grease in it. It's very simple, but it's effective. And then you can see it has gears and pretty cool little arm things.
And show how the flaps would work in water.
Yeah, the flaps. So obviously the flaps right now are just hanging, but you can imagine if it was in water, on the downstroke, it would go like that. On the upstroke, it would stay normal to the motion of the fluid. It would just, there would be a lot less drag on the upstroke, but on the downstroke, they would flatten out.
Yeah.
So it goes up and down.